I found it. I found it in the book. This property, limit as x approaches 0 of k equals k. Actually, let's just say limit as x approaches c, where c is any real number. Limit as x approaches c of k. I found it. It's right there. Under properties of limits. But you see what they did? They put properties of limits. That's like a heading. Then they gave you two of the most fundamental important properties of limits. And then they give you a box with all the properties of limits. Why didn't they put these properties in the box that says properties of limits? Why do you have properties of limits and then a box with properties of limits, but two of the properties of limits you didn't put in the box? Nice. Okay. Now, we have that to use. Now, here's something else fun. So number 28, like number 25, which you will have to do, number 28 really is going to require a lot of creativity to solve that. So I'm going to model that one for you. And you've got to figure out number 25. It's completely different. It's not going to be similar. I'm just saying it requires a similar level of creativity. So one of the things that I noticed right away in number 28 is that unlike all the other problems we did with sine x over x, this one has sine in the denominator. And I don't have sine in the denominator. It'd be nice if there was a sine 3x over sine 3x, because then I could cancel them out, but it's not. And sine 3x and sine 4x they don't have any obvious way to simplify them. I mean, you could maybe do something with x plus 3x and do like the, what's that sine sum formula? It was like sine of a plus sine of a cosine b minus cosine a sine b or something like that. I have to look it up. Anyway, you could try something like that, but it might not work. It might. There's probably an easier way to do it. So my thought on this was, just look at the sign in the denominator. Let me think about this. We know that limit as x approaches 0 of sine x over x equals 1. Would it make sense that limit as x approaches 0 of x over sine x would also be 1? To me it does, but let's see if we can show why it is. Because if I first just manipulate this algebraically, x over sine x is the same as 1 over sine x over x. In other words, all you've done here is flip this one over, taking a reciprocal. So if I do 1 over it, then I'm going to have the same thing. Okay, now I have this limit, this one that I know the limit of. Can I get that limit in there? Well, the answer is yes. If I think about this property, about the quotients, so the limit of a quotient of functions is equal to the quotient of the limits. And then just think that the top limit, f of x, is 1. And then the limit of f of x, the limit of 1 would be just 1. So I'd have 1 on the top, and on the bottom I'd have whatever the limit of g is. So that's actually by combining this property and this property. And you don't have to really refer to those properties. Eventually you're going to get the idea that limit is pretty flexible, and it can move into a lot of different kind of functions. There are very specific ways we'll talk about later. So this is equal to 1 over limit as x approaches 0 of sine x over x, and I know what the limit as x approaches 0 of sine x over x is. It's 1. Therefore I have 1 over 1, and that's 1. Now I have the useful conclusion that limit as x approaches 0 of x over sine x is also 1. All right, now how does that help me here? I have to still be pretty darn creative. All right, so here's what I did. There are probably lots of different approaches. So one thing I did was using that property that I can factor out a constant. I just did that right away because I feel like this 3 is just in the way. If it was 3x, it would be really helpful. And there might be different ways, like put an x in and cancel it out. Maybe that would be a good way to do it. Actually, I kind of like that better. But I'm going to go with what I did first. I just said, let's get that 3 out of there and just deal with the limit as x approaches 0 of sine of 4x over sine of 3x. Well, what I want that to be is I want to be able to have my sine of 4x be over 4x. And I want to have 3x over my sine of 3x. So let's see how I could just write that. So, sometimes mathematics is about write what you want and then think about how you're going to get there. So I want sine of 4x over 4x. I want 3x over sine of 3x because this one's going to be 1 by this property and this one's going to be 1 by this property. But how can I just put that 3x and 4x in there? Just as we talked about before on number 22, was it? I can stick in things that I want as long as I also simultaneously cancel them out. And that's really a very standard mathematical procedure. So I'm going to say, okay, I wanted this 4x in here, so I'll just cancel it out right there. And I wanted this 3x here, and I'll just cancel that out right there. And as long as the 4x over 3x doesn't cause me additional problems, it will be a good step to take. Sometimes it does. In this case, it adds an extra step, but it's a step that I can handle, so we like that. So this equals 3 times the limit as x approaches 0. So the next thing I'm going to do is use that product property, right? The limit of the products is equal to the product of the limits. So I'm going to be able to break this up into 3 different limits. Limit as x approaches 0 of sine of 4x over 4x times the limit as x approaches 0 of 3x over sine of 3x times the limit as x approaches 0 of 4x over 3x. All right, now I've got the 3 out here. This one is 1. This one is 1. And this one is rational, and I can reduce the x's because the limit is at 0, so the x's aren't equal to 0. And then, but I can't just say it's 4/3 right away. I'm going to say it's equal to the limit as x approaches 0 of 4/3. Then I can multiply these together and say that's 3. Then I can say, just as we set up here, the limit of a constant is equal to the constant. That's 4/3, and that equals 4. Now I know the limit's 4, and that's how you can justify that this one is 4, like the book says it is. All right, so we'll go next and see if we can clean off the rest of these problems in the next couple of videos. Finish up 2.1.